Hello, my name is Jamie Ward and this is a short film on setting up the single-ended tenoner. The tenoner we use to cut tenons on rails. So we've got a frame, as you might remember the stiles, the components go up and down, and the rails, the ones that go across. So we're cutting tenons on the rail. So naming some parts on the machine, we have the sliding table. So our components, our rails sit up against the fence here, and we move them past the cutter heads. We have a mechanism for holding them. We have to adjust the clamping mechanism, moving these together, otherwise it locks up. And we always put a packing piece in here. We also have the fence and chip breaker. We have a turnover stop for repetitious cuts. And we also have a spring-loaded stop in there. And then looking at the heads, so we have the locking levers for the rise and fall, so the bottom locking lever for the bottom head, and the locking lever for the top head and the wheel adjustment there. We also have this mechanism here where we can actually lock the heads together, so we can then, once we've got the set of the tenon, we can move the heads together as a pair. Control panel, start and stop switches there. That's for the top tenon, bottom tenon, and the scribing heads. We also have the gauges on the side, so this allows us to set the wheels. So at the moment they are square shoulders, they're in line. We can set them offset shoulders by moving the heads in and out. And this particular machine has a retro braking, so a box on there which stops the machine within 10 seconds. So we have the rails. So first of all we need to mark the end. So we have the mortise gauge still set from when we marked out the mortise. So we've already marked out our face side, so we've selected which is the best side. We then gauge the end of one of the rails, which enables us then to set the machine up, the top and bottom tenon, stock against the face side as we did with the stiles. So we need to set the pressure, so at the moment it's a little bit high, I think. So we can move this part of the table in and out depending on the length of the rails. So the pressure at the moment is a little bit tight, so we can set the pressure, move these two together. If we move one at a time, they'd actually jar, they jam, get loose. So set the pressure. So I've got the lines, the gauge marks on the end. I'm just going to bring this up against the tenoning heads. I then come round to the side. Okay, so I come round this side to set the blocks, top and bottom block. So the machine is isolated. I've undone the locking lever for the bottom block, undid the locking lever for the top block. And then before I touch the cutter block, just to point out a bit of health and safety, I'm going to touch the block on the side to allow me to set the block up to the gauge lines, so I'm not coming in contact with the cutting edge of the knives. So the moment I can see that the bottom block up against my gauge line is probably about 5mm too low. So on this machine, the wheel to adjust the bottom block is the one on the back, and then bringing it up within a minute, within a mil, well, up to the line, lock it off. Do the same with the top block. So this is a very approximate setting at the moment. Okay, and then the only way really is now to test the cut. So just to point out, we have the fence. This fence is useful because it stops the breakout when the tenon head comes around. It tends to break out on the back edge here. It also gives us a datum, a line to work to. What I will do is, in a moment, I'll leave it as it is until I've got the machine set up and ready to actually start cutting my tenons So once I've gone past the setup, the testing stage, I'll unscrew this fence, also a chip breaker, and move it along a touch and put a fresh cut in there, and therefore get a better finish. So health and safety, I'd wear ear defenders, eye protection, left hand on the handle, right hand here, and when feeding the machine, when we started it up, I would feed it at a constant speed, not too fast, not too slow. So, with the machine, with the tenon, I would get the tenon fitting first. So the moment I can see that the tenon is a little bit loose. So I'd concentrate on moving one block. So if the tenon's too loose, too thin, then I'd move the top tenon up a touch to make it thicker. If the tenon's too tight, then I would move the bottom tenon up to make it thinner. I wouldn't worry about the position of the tenon in relation to the style. I'd concentrate on getting the fit right first. So this is a little bit too loose. So what I'm going to do is move the top tenon up a touch. So locking lever off. I break this down into a clock. In other words, 12 o'clock, 3 o'clock, 6 o'clock and 9 o'clock. And I'd move it a quarter of a turn. So I'm going to move it from 6 to 9 and then try again. So, I have the fit. I'm happy with the fit of the tenon in the mortise, so it's holding it. So, what I can see, if I look at the face sides, I can see that the rail is a little bit proud of the style. If I bring round the face sides together, I can see that the tenon, so face sides flush, I can see that the tenon, there's a gap in the mortise. So in other words, the tenon is too high. The tenon is too high. I need to then lock them together as a set, as a pair, and then move the tenon down, in this case about 2 millimeters. So locking this together, or the heads together, 2 locking levers there. We have this lever, put pressure onto. Either wheel, either way, we can move just a small amount and it will engage the lever. She's done it there for me. So that, by doing that, if that didn't go in there straight away, you could just move these a touch. That locks the heads together. So now they're together as a pair. And I said that the tenon wants to come down a couple of millimeters. So what I would do now is move this down, so I know on this machine down is anti-clockwise, and move it a quarter of a turn and try again. So face sides together, just a fraction. Tenon fraction high, so still down a touch more. Locking lever, lower, anti-clockwise, quarter of a turn. Try again. There we go, flush. So I said the last thing I would do before actually start cutting my tenons is I would unscrew the chip breaker and move it along a touch to stop it from breaking out. You can actually see on here a bit of breakout because that chip breaker wasn't working. So by unscrewing so move it along 10 mil so I can gauge it from the table. Just make sure that that fence is down in there square, which it is, and then I'm just going to cut through that fence. So once we've got the machine set up, so that we've got the tenon fit and we've also got the position of the tenon, we've moved along the fence, put a fresh cut in there so it's now acting as a chip breaker and a datum to work from. You will then mark out your shoulder size. So here's a frame we've talked about before. The shoulder size I'm talking about is the size between the stiles, so in this case from there to there. That is the shoulder size there. So on the rail, that would be from here to there. I've marked out my rail, and then you only really need to mark out one component because we're going to be able to set stops up and then put repetitious cuts in going off those stops. So coming onto the machine, I'm going to place the rail, so the pencil lines I've got on the top here, up against the datum on the fence. So placing that up against the lines, aligning the lines. I'm going to use this turnover stop for my first tenon. So each tenon, first tenon will be used or go off this tenon, this stop. And then my second tenon, so I turn around, keeping face side down to the table. I can undo a locking lever here, and there's a spring-loaded stop there, and then bring the pencil line in line with the shoulder from the chip breaker, the fence. Lock packing piece in there. So therefore, each tenon will be turnover stop, first tenon, take it out, turn it around, second tenon will go off the shoulder, off the cheek here. of the first tenon. So it's important to get the shoulder correct from there to there. The last thing to do is to check that everything goes together. So we've got our rails with our tenons, our stiles with the mortises, face sides want to be together. So our face side and the face edge on the inside edge. There's our frame.